Hi, I'm Dominic with SLOAN Technical Services Department. In this segment, we're going to discuss measuring pressure at the valve in the restrooms. And we're going to be using the EBV 375A pressure cap gauge. And much like the A115A for manual valves, this one is designed for the top-mounted sensor-operated, battery-operated, or hardwire version sensor-operated valves. So using the EBV 375A pressure cap gauge, which is designed for the top-mounted sensor-operated flushometers, this one utilizes the whole base assembly of either the SLOAN Optima Plus or the Solus Optima Plus, the G2 Optima Plus, as well as the Ecos Dual Flush flushometers. And this enables you to use the existing module that is underneath the cover to activate the valve and to shut it off and give you pressure readings. First is we're going to start by shutting the water off. And in that case here, when we have the vandal-proof cap, whether it's the screw-on style one or the free spinning one, we can use the A50 SLOAN wrench to remove the vandal-proof cap. In this case here would be to pop the free spinning cap off, or to use the hex designed into this to loosen the cap to get to the screw, or in the case of a concealed valve you'll have a wheel handle, or in some cases an exposed valve will have a wheel handle. So the first thing we're going to do is activate the valve, and while it's activated and flushing is what we're going to do is we're going to turn the water off. And if it shuts off before you have a chance to get the screw all the way turned to the off position, go ahead and flush it again. When the water is shut off and you turn the valve off, what you're doing is you're beginning to compress water into the valve, which is going to increase the pressure load in the body. So that's why it's always a good idea to activate the valve while turning the water off. So this way it makes it for an easy sweep on shutting the control stop down to shut the water off to the valve. And just to be sure, we activate it one more time. Now, normally, with all the rest of the facets and couplings that are on the flushometer, you would use a smooth-jawed wrench, whether it's our A109 adjustable plier wrench, or it is a pipe-style smooth-jawed wrench, or a spud-style smooth-jawed wrench. And the reason being is we don't want teeth, because teeth involve using force to bite into it, and what you wind up doing is you compress couplings, whether it's at the vacuum breaker or at the control stop for working on the O-ring or the tailpiece, or even at the spud. What you wind up doing is squeezing the couplings, and that grinds the threads together, and it gives you a false tightening feeling, especially if you should have a handle on the side. In this case here, because we've got the top-mounted units which have a smooth round locking ring to secure it to the valve body, we're going to use the EBV 22 strap wrench. Now, you can use other strap wrenches. You just want to make sure the type that you use isn't a chain link style one, or ones that have small little metal buds on there, and what they'll do is they'll dent into the brass or scratch the finish. So we're going to put our strap wrench on. We know that our water is off, and then we're going to turn the locking ring to loosen it up, and then we're going to take it up the rest of the way by hand. And in doing so, we're going to take the diaphragm with it. While we take this apart, water is going to spill out, so it's a good idea to throw a towel around the bottom of the flushometer to catch any water that spills out. So the diaphragm is going to pull out with the head once we remove it from the flushometer. So there is a little trick to taking this out, because if it's been in there a while, this could be a little stubborn. And what we can do is we just push these two little tabs on the bottom of the little flex tube that runs through the middle of it. We force it in a little bit, and then we just take the diaphragm off. Now that enables you to grab it right at the regulator and pull this out. Then once you do that, we'll put it back together, and you tug on it till you see it and hear it lock into place. And then we're going to take our pressure cap gauge for the top-mounted battery unit. And in this case here, we're going to wet the O-ring at the top of it, and then we're just going to push it back in. It's not overly necessary that it hangs by itself. You can actually put it inside the valve body and then drop this on top of it as well. Water pressure will force the O-ring up. Sometimes it may not, and you get a run on, so In that case, what you can do is you can do the reverse of how I showed you to remove it, is to get to the flex tube itself. That way you can get up at it and force it up in there to make sure it just gets started. Once it's started, water pressure will take care of the rest. Then we slide this over, tug on that, and then we're going to drop it down, and we're going to tighten this up. To tighten this up, after I get it hand tightened, I'm going to use our strap wrench, the SLOAN EBB 22. And what we're going to do is just get that on there. I get it tightened as good as I could by hand, and then I'm just going to snug it up with the strap wrench. Now you see the gauge moved when I tightened it up. What you can do is you can loosen it and backspin it a little bit, but for the most part, as long as the gauge is facing forward, you'll be able to get a read on it. So in case it makes it difficult to read, we're just going to loosen it up again, and what we're going to do is we're going to backspin it so it faces approximately the 5 o'clock position, and then we're going to tighten it back down. So that way, once it starts spinning with it, which is normal, and it should line up facing straight ahead. So now that I have this tightened up, what I'm going to do is I'm going to take the 2 screws up from the top mounted sensor operated battery unit, and I'm going to get to the control module, because that's what we're going to use to activate the flushometer when we get ready to turn the water on. It's a good idea to have the module ready in hand, or should you have a spare part on your shelf or in your inventory, it's a good tool to use along with the gauge. So the wrench that we use to loosen the 2 screws on the cover amongst all the platforms, the top mounted battery or hardwire units, is a 7/64 hex wrench or a 7/64 Allen wrench. So once you have the screws loose, we're going to remove the cover, and then we have the control module, and what we're going to do is we're going to unplug it from the solenoid. So once we unplug this from the solenoid, we're going to plug it into the solenoid that is located on your pressure cap gauge. So now we're ready to go, but before we turn the water on, no different than when you're first installing or servicing one of the units, is we want to dry fire the unit, and you'll hear the clicking of the solenoid. Now this is a SOLAS module, so normally if it was the standard non-solar units, you would hold your hand in front of it for about 10 seconds and then you would take your hand away. So in this case here, we've got the little contact pads, and those are the same ones that transfer up to the contact buttons or the touch buttons on the solar units, whether it's a single one or a dual one. So in this case here, if I touch these, it's going to activate the solenoid, and in doing so I'm going to hear the first click, followed by about 3 seconds later you're going to hear more of a bump than you will a click. So I don't know if you could hear that. I think it picked up on my microphone, but we made sure that the solenoid opened and then closed. And then now that we know it's closed, then we can turn the water on. So but once we hear the 2 clicks, then we're ready to turn the water on. And once you turn the water on, the valve is going to begin cycling itself off. Now when it's doing that, the needle is going to be a little jittery. There's some air to work out, but then once it cycles off, it'll raise to your static pressure. So let's head into the restroom. We'll attach the valve and we'll do some basic readings and give you an idea of how to use the gauge for measuring pressure. We're in the restroom. We're at the flushometer here, so we're going to install the top mount battery type unit flushometer gauge. And first thing is first is we're going to turn the water off. So we'll use our A50 wrench, which slides right behind the free spinning vandal resistant cap. We'll take that off, and we're going to flush and turn the water off at the same time. Okay, so the water's off. We want to click it, flush it one more time just to make sure that there's no pressure remaining built up in the valve body. And so now we're going to remove the head. So we're going to use our strap wrench to remove the head, and just to get it loose. Once we get it started, finish up by hand, and I put a towel around the base here to make sure that, because you're going to lose a little bit of water when you take that out and it spills, just makes it easier for the cleanup. And the diaphragm will be connected. So we're going to Spill the water inside. If you pull a little tug on it, it doesn't want to come. We just squeeze these two little tabs, push the tube up in there to remove this, and that'll make it easier to remove the flex tube in there. So we're going to set this to the side, and we're going to put the diaphragm back together, and then we're going to push it up into the bottom of the unit. Again, sometimes if it doesn't stay up in there, you can drop the diaphragm inside the valve body, and then you can tighten it up. Water pressure will force the diaphragm up into the tube. Now you see I'm tightening this and the valve wants to turn a little bit, so I'm going to keep it to the outside so we can see the gauge better. I'm going to hand tighten it, and then we're going to finish tightening it up with the strap wrench. So we tighten down the gauge, and I've got it facing a little bit to the right here to make it easier to view in the camera, and I am loosening the cover here because I need this module to activate the solenoid. And if you notice, it's the exact same base plate assembly that we use on all the top mount battery and hardwire units. So in this case, this is the Solus, so these pads are active, and what I'm going to do is I'm going to plug it in, and in the case if it doesn't have the pads on the top where it'll be a G2 or Ecos dual flush in sorts, you just hold your hand in front of it for about 10 seconds, and then when you take your hand away, you'll just point it in a direction where there's no target to detect, and we want to get the solenoid to click. So that way we're opening it and closing it. Make sure it's in the closed position before we turn the water on. So we're going to turn the water on, and the valve will cycle itself off. So now the valve is going to cycle itself off, and I usually start with about 1 1/4 turns open or so, and then from there I'll adjust it by gauging the flush, and you'll see that the gauge has steadied itself to the static pressure. And anytime water is being used in the facility, you'll see the needle will drop, and this is what we're looking for. So right now, with no flush activating, we're reading the relative static pressure. Anytime water is being used, whether it's a sink or someone flushes, or say there's a shower going, you'll see the needle will drop. So we have the static reading. In this case, it's reading right around 70, 71 pounds. And when I activate, you'll watch the needle will drop. And for about 2.5 seconds or so, because the solenoid is open, it's not going to register much pressure in here because it's being relieved through the valve until the solenoid closes. Then the upper chamber will, you'll see the needle will jump up a little bit. So this is what we're going to look at here. And once it shuts off, we rise back to the static pressure. During the flush, what we're looking at is on the bottom end, we want to be right around 20 or a little above, which is good. Once you start getting higher than that, the toilet will start splashing, which is telling you got too much pressure coming into the toilet. So when we activate it, we're going to drop down, then the solenoid closes and it comes up a little bit, and there's basically our peak flow. It's right around 18 to 20 pounds. Again, this is a approximate. If it was too weak, it would be a real sluggish flush. But I've got it open 1 1/4. I'm going to go about 1 3/4 of a turn, and I'm going to activate it. So you'll see my pressure is a little higher. That's right where I want to be. I've got a good rinse in the toilet and a good evacuation. So that tells me I've got good flow pressure to this closet. So by using the pressure cap gauge now, we can gauge the water pressure at the water closet at the flush valve. So this way it gives us an idea of what we're working with in the building. And then when we activate a flush, you see the needles bouncing, there's other water being used, and we can see what the pressure drops are. What we don't want to see is the needle dropping all the way down and lingering. When you flush at the valve, as I'll show you, it'll linger down right around 20 and then slowly come back up as it shuts off. Now we rise at the shutoff. And then once it shuts off completely, the static pressure builds back up in the valve and it registers what the static pressure is in the facility. So once I've taken my readings to give my assessment at the flushometer in this location where the restroom is at, depending on whether there's elevation or a long distance in sorts, this is what I was looking to do to make sure that, say, if I had older toilets and I'm switching over to 1.28, that I want to make sure that the closet there will give me good delivery. One other thing that we could do is we could see what the capacity of flow is to this valve is. I can turn the stop wide open, and then when I flush, now the flush is going to be real aggressive and it might start splashing, which is normal if you've got good flow pressure in your facility. So the peak flow is registering right around 35 to 40 pounds. Again, it's only an approximate measurement, but this gives me an idea that I've got some good healthy flow to this restroom. Once you're done with that, then we can turn the valve off because these weren't made to stay on. It's just temporary use to take measurements, and then we put it back to normal. So I'm going to activate the flush and I'm going to turn the water off. Now that it's off, I'm going to activate it one more time. You'll hear a couple of clicks. And that way I know that I've relieved all the pressure in the valve. I'm going to remove it and then put the head back together. So, are you still recording?
Yes, sir.
Okay. You can just take little snippets and show me putting it all back together. Because I removed it and I replaced it, I'm going to dry fire the unit by just dry firing, activating it to turn on and off, and then I'm going to bring my water back on. So I'm going to turn my water back on. Again, about 1 1/4 turns to start, and I'm going to gauge the flush. If it looks a little bit on the sluggish side, what I'm going to do is adjust the stop. So I activate the flush. Usually you want to activate it 2 or 3 times. We're going to purge all the air out of it. And then at that point, when I flush it, I want to see a good healthy flush. I don't want to see the water start ramping up. I want to see it all finish into the trap. And that way I know I've got the proper water pressure to the valve. Because too much can cause agitation or can cause shredding of the toilet paper and sorts. Not enough, of course, will cause rollback. So what we want to do is just find the happy medium, and then we're good to go. Just a little bit more. I should be good. I want all the water to swirl right into the trap. And then we're good to go. I'm going to put my cap back on, the control stop, and that's how we measure water pressure at the gauge. Thanks for spending time.